Right now, I want to talk about the forces of the atom. To understand the inner workings of the atom, we have to talk about how it interacts electrically between the electrons and the protons, and the protons themselves in the nucleus. So, the inner workings of the atom requires us to look at electrical interactions between electrons and protons in the nucleus. So there are two types of charges. There's positive charge, which is associated with the proton charge, and there's negative charge, which is associated with the electron charge. The only thing we could say about these charges is how they interact electrically. So there's the electrical forces behave as follows. If I have a positive and a negative charge close to each other, they feel an attractive force. On the other hand, if I bring a proton charge together like this, where there's two of them, or two negative charges close to each other, what we find here is that they feel a repulsive force where they push off each other. So to look at the inner workings of the atom, we essentially need to talk about two things. First of all, we need to talk about the Rutherford model of the atom, and what that ultimately tells us about, it tells us about the attractive force between electrons and the nucleus. And the second thing that we want to talk about is that atoms are not empty. And ultimately what that's going to tell us about is the repulsive electrical force of the nucleus. So let's focus on the Rutherford model. Atoms exist because there's an electrical attraction between the electrons and the positive nucleus. The first model of the atom was was first given by Rutherford in 1910, and this model is also known as the planetary model. So the picture that he has of the atom at this time here is that you have a positive nucleus and you have a negative electron. and this electron is orbiting the nucleus, and it's very similar to the planet Earth orbiting the sun. But the problem with this model here is that any electric charge that accelerates will emit electromagnetic radiation. So any accelerating electron will emit electromagnetic radiation. And this word, electromagnetic radiation, is a fancy word for light. When an electron is accelerating, it loses energy by emitting this radiation. Okay, so once again, this accelerating electron will lose energy by emitting radiation. This is exactly what happens in your microwave oven. So as an analogy of what is going on, let's talk about a microwave oven. How does a microwave oven work? A microwave oven, when you look at it, we imagine that we have a metal box, and in the back of your microwave oven you have a box. This box is probably the size of a coffee cup, and when you look at this box here, this is what's called a magnetron. And what the magnetron does is that this is what creates microwaves in your oven. Now, how does it create microwaves? So it turns out that it looks something like this. So the first thing that you should think about here is that you have a disc that's a magnet. So if I'm looking at this thing here, I imagine that I have some disc, and this here is a magnet. Now what happens with this magnet here is that there's a post in the middle, and the electrons are actually made to wiggle as they go around. So if you were to look at this thing, the electrons are actually wiggling around as they go around this post here. So what you're seeing here is that right in here you have electrons going around in circles, which means they are accelerating. And what happens here is that there's now a tube that sticks out of this magnetron, and this tube here, what it does here is that then the microwave radiation comes out. So this is microwave radiation. So how do you get the microwave radiation? From the accelerating electrons. But there's a problem with these electrons. accelerating electrons lose energy. And because they lose energy, the electrons would quickly come to rest if they are accelerating like that. So how do you keep electrons from not losing energy? Is that what you do here is that power and electrical energy is given to the electrons so they can continue going around in circles. But if they keep going around in circles, then that means that they continually emit microwave radiation. If electrons are not continually given electrical energy from the outlet, the electrons will crash. In other words, if these electrons are not given electrical energy, electrons will crash into the central post and stop moving. Now let's go back to the Rutherford model. In the Rutherford model, electrons accelerate around the nucleus. So that means here that I have my electron, I have my positive nucleus, so if it's in this planetary orbit around, what are we actually seeing? So as the electron is going around, it constantly is then going to emit radiation. But this radiation means electron loses energy. But if it loses energy, its orbit then gets smaller. So when you look at the orbit is getting smaller because it's constantly emitting the radiation. And as it constantly emits the radiation, at some point the electron will crash into the nucleus. So an electron will crash into the nucleus because it's constantly emitting radiation until the atom stops existing. Therefore, the Rutherford atom is a bad model of the atom. So the common picture that you see of the atom going around in circles is not a good model. The atom ceases to exist. There has to be a better model because atoms do exist. That's where quantum mechanics comes in, but I'll save that for later. I now go to the second piece of atoms are not empty.